Hi, dear professor. I hope you are doing well. In this video, I will explain my OpenMP array smoothing program, which demonstrates parallel computing concepts in the programming language C. Um, the program performs several operations on a large array, generating generating random numbers, computing the standard deviation, applying a smooth function multiple times, and then measuring the performance. The main characteristics is like this. Um, Generate a random array in parallel, compute its standard deviation, repeatedly smooth the array to reduce the variance, to measure the performance of scaling with different thread counts. So I will work through the code, explain how OpenMP is used for parallelization, and show how to compile and run it with performance results. Um, I have included standard libraries like StudioS.s, math.s for math, time.s for time, and OMP.s for OpenMP support. The main function is random array, the past measure function, which fills the array with random values between 0 and a given scale. Inside the function, I used parallel program, uh, Pragma OMP parallel, which creates multiple threads that is generate random numbers independently. I also use rand r instead of rand because rand r is thread safe. It uses a separate seed for each thread to avoid data races. The next portion, there are some parts, like first one is sum. Um, Sum function which computes the total sum of the array using a parallel reduction. And there have a command like pragma OMP parallel for reduction, which allows each thread to compute a partial sum and automatically combine the results at the end. Then the standard deviation. Then this function computes the standard deviation. It first calls the sum um, to get the mean and then calculates the variance. This one um, using another reduction loop. This approach ensures both the mean and the variance are computed in parallel, making it much faster for large arrays. Then I use the smooth function, uh, mm, filtering to reduce fluctuation in data, where I use the formula this one, and also it's a temporary array. The loops uses pragma OMP parallel for to update all interior elements concurrently. After smoothing a second parallel loop, this one copies the new values back into the main array. Um, Both designs avoid race conditions by using a temporary buffer like temp. During the update, and it stores the result there using the array I. And then after that, it's the main function. This one, um, it reading by two command line arguments. The first one, the array size, and the second one is the weight. The array are dynamically allocated with the malloc, and the program prints a summary including number of threads and some other calculations like random generation, initial standard deviation, smoothing where I use 20 iterations, the final standard deviation. Also, I print the result like the total runtime. Then I tabulated all the results there, and using these two formula, the speed up and efficiency, I calculate the speed up like this and the efficiency like this. And using these two value, I created a figure using Python, where the first one is for speed up and second one is for efficiency. Okay. So it's indicated that this one indicates that when the number of thread is 1 to 16, it's almost like a linear one. Then it's uh, re, um, then it reduces. And the second also showing the clarifies the reducing condition. Um, so now I will show how can I execute the code using the SPC. So there have my code. I need to compile this code first. Then I will use the thread number 1, 2, 4, 8, 16, and 32. This is the result for thread 1. If I use thread 1, like this is for number of thread is like 2. Then the number of thread is 4. Then the number of thread is 8. Then it will like 16. Then it will like 32, the final one. So as we generate a random array, say, so my result and current one is little bit difference, because every time it generate a random array. And when I create the report, I tabulate all the result is there, and I use the n equal total array size is 10 to the power 7. The weight is 0.6 and the number which is 20, but then I need to correct it. And so finally, the these values will vary depending on the number of threads which I input. And but the idea is to demonstrate how parallel computation dramatically reduce runtime compared to a sequential approach. In summary, this program illustrates key features of the OpenMP, the benefits of using OpenMP, like parallel and directives, reduction for safe parallel summation, thread safe random generation using the randr, which already described little bit earlier. Also, accurately calculating the time. I use OMP hyphen get hyphen W time, like this one. So this all about my presentation.